Well, let's get started. Welcome everyone to another Midweek with Max. This is Rick, joined by JCV, Joshua, who's not allowed to talk on Discord because of Discord, Marco when he gets back on stage, Jeremy, and of course our co-founder Max Sanchez. So let me kick it over to Max for the weekly update, and then we can get in some questions and other things.
All right, sounds good. Welcome everyone to another Midweek with Max. Engineering updates, making a lot of progress with MinerFi. So we've got I think we talked last week about some of the updates and improvements we're making to the BNB TSS library. So we've finished those up, and that's going out to auditing shortly. And we're also finishing up the work on Continuum, which is the actual daemon that uses that library and does all the threshold signature magic behind the scenes, as well as the smart contract system on chain that it interacts with. So all of that is moving along and will be in the queue for public testing at some point in the relatively near future. So if you want to be one of the first ones to play around with that and get some small bounties for testing and giving feedback, definitely make sure you're in the beta testers channel. Beyond that, we've also been making progress on the ZK proving marketplace. So that's coming along well. We're working on hooking it up to some of these applications that are going to be actually using it as a proof consumer. So being able to do ZK proofs for Oxygen, ZK proofs for some parts of MinerFi. A lot of MinerFi ZK proofs are things that handle sensitive data. So it has to be the actual operators or participants in the threshold signature scheme that generate the ZK proofs. But there's one part of it that's this very large, expensive aggregation proof based on public data that basically just proves the entire ceremony was completed correctly by all participants. And that part can also leverage the ZK marketplace. So working on hooking those up and testing all the components in concert together. I've also been working on updates to the veHEMI system for restaking, basically turning veHEMI into that shared security system that lets us use it as we start launching these decentralized components, and then also probably as maybe a phase 2 as a governance gated thing, but opening it up to anyone to use as a economic security system who wants to use it for their own application they're building. So making progress there, and I think those are all of the major things. We are going to be doing a ZK Marketplace AMA discussion on Spaces, YouTube, and I guess also LinkedIn still. So I think that's scheduled for Friday. I'm not sure if we've announced a time for that. If we have not, that should be announced soon. So if you want to learn more about the ZK Marketplace, I think we'll talk about that a little bit today, just so people understand kind of what it is and how it fits into the overall plan for Hemi and what it means for people who want to participate either as using their veHEMI positions in some of the roles that make the marketplace run, like evaluating and voting on compute complexity of jobs, or participate as a ZK prover contributing computational power with CPUs or GPUs they have. We'll touch on that briefly today, but then really deep dive into it on that live stream on Friday. And I think that's pretty much it. We are going to be shipping the pot payouts algorithm soon. There's really no reason for delaying it other than just other things taking priority. Everything's ready for deployment. We just kind of move stuff around and get contracts deployed, tokens moved, all of that, which takes some coordination effort. So that is still coming soon. And VBK, no updates on that side. But again, it is still in the works and coming in the near future as well. And we also have some things behind the scenes that we're working on for some new interesting things for the community. So I think I'll, for this one, throw it over to John and possibly Rick if he has anything else to chime in with, because they've been working on some of the new initiatives and ideas around sort of a new set of things for the community to do and engage in. So with that, I'll throw it over to JCV.
Okay, so I'm not actually going to announce what we're doing yet, but want to say that in the coming month, we will make a much firmer announcement for there are going to be some changes to the community. We're hoping to, introduce a bunch of new things, some things people can actually do, try to, just get the community where we know you guys can be. There is a strong possibility that the intern may get another chance to do something involved in this, assuming Rick lets him out of his cage or whatever, however he's
Oh
locked him
boy.
up. But yeah, again, it's a slightly vague update at the moment, but again, in the next month, we will make a much firmer update to explain exactly what's going on, and hopefully it will be something that will be fun for everyone involved in the community. Rick, anything you want to add?
It will involve Guild, some new shows to watch.
God damn it! That's how I was planning to start it. That yes, this will correspond with the launching of Guild. That just seemed like the right time to do something big.
Yeah, and there's going to be some changes to Midweek with Max. There's going to be some new weekly activities and updates, and also a community YouTube coming very soon. I hate to use very soon, but I just used it. But it'll come along with the rest of these VEG announcements. But it's going to be really cool, and I think people are going to enjoy it.
Yep, because if we're gonna have a community here, we want it to be fun and we want it to be a participatory. That's sort of a word, right? Yeah. We want it to be something that people can be involved in and something fun, and so keep an eye or an ear or whatever you use to pay attention to this open for it.
Yeah, that was a good way to wrap that up. Let's
I was trying to let it trail off there. I need to you see if you had the damn soundboard from the other calls, you could have done something.
yeah. The soundboard might be coming back. we'll work on that. All right, let's get into some questions. The first one being very timely, regarding the OG role. Does anyone want to address that?
Yep, we do not have an updated date to announce right now, but hopefully we will soon. We're also looking at potentially making some small changes to how the program's structured. So nothing major, but we're still discussing, or a new discussion item is potentially tiering it by people who have more than the minimum criteria. And so there's a little bit of extra engineering around that required as well. So hopefully next week we'll have an updated time for that, but a lot of things are in flux and a lot of the engineering capacity is now pointed over to doing the opgeth to opReth translation that we now have to do to be compatible since Optimism is deprecating opgeth upstream. And so that's been shifting some engineering timelines around a bit.
So if you want to blame someone, find a Rust developer, any Rust developer, and blame them because it is their fault.
Yes. But yeah, we're still working on getting an updated timeline, but as soon as we have a actual date to target, we will announce that.
All right. Let us see. What is Hemi's plan to grow the Hemi ecosystem?
A couple different pieces. So first is the upcoming grants and bounty program. So we're going to be announcing a more formal version of that, possibly as part of this new set of community initiatives. And again, if there's anything that you're interested in developing now, definitely reach out. We've had some people reach out with some interesting ideas. So if there's something you want to build, either something on-chain DeFi application, something you want to contribute to the code base, or some sort of community tooling, things like stats dashboards, things of that nature, definitely reach out in the meantime. But we will have a more formal program along with some applications that are unique to Hemi that use HVM in ways that let you build things you can't build on other networks. That we'll also be putting out there as sort of requests for implementation for anyone who wants to take a stab at any of those. So that's one prong of it. The next prong is with the ZK marketplace, which I'll get to in a bit more detail later today. But as part of that, we're building a ecosystem that makes it easier for developers to build ZK accelerated apps or ZK augmented apps. So right now, developing things that require ZK either for cross-chain interoperability or offloading very expensive computes off-chain is pretty difficult. The existing proof marketplaces work for some types of apps, but they're not very genericized in a lot of ways. They usually require, submitting ZK proof jobs that have the actual inputs to the program generated by somebody and then pushed somewhere like IPFS. There's a lot of the ZK workloads that developers actually want to build, especially around DeFi applications, are based on the results of the computation, where the inputs can be gathered by somebody who's aware of the protocol. And so we're doing some interesting work there to make that more accessible for developers, so you can define ZK proofs in terms of, ZK prove this thing about Ethereum versus run this program with these inputs that have been generated by some off-chain process that is trusted to generate those, push them up consistently, things of that nature. So that's going to be hopefully an accelerant for people building interesting ZK applications. It also expands beyond just Hemi. So even though the marketplace itself runs on Hemi, the ZK proofs can be used for any application on any chain, as long as you're able to plug into the proof definition framework we're working on for that. Beyond that, definitely continuing to do BD, get other partners lined up who want to deploy on Hemi and do interesting things. Working on increasing TVL, or actually useful TVL, in applications like DEXs and lending protocols. And I also can't share too many details on this yet, but there should be an announcement relatively soon about some new pretty cool stuff we're doing with stablecoins. And so that should also be an accelerant for liquidity on chain and things that we can do between Hemi and Ethereum with stablecoins, and also open up some more interesting avenues for developers around the StableFi space.
All right, awesome. Exciting things coming. I'm not going to say soon, but coming in the near future. Let's see. Do you have any timeline of visibility on when HBUSD may go live? And could you clarify how HBUSD is designed to differ from something like Luna, especially in terms of collateralization and stability model?
So HBUSD is really just a economic experiment. So it's something that is basically a one-way peg, where you can burn Hemi tokens to get HBUSD at the current value of Hemi tokens to USD, but there's no redemption, collateralization, backing, anything like that. So it's not something that is part of the major Hemi roadmap, or that we have any particular use case for beyond just an interesting economic experiment. So all of the stablecoin stuff that we're doing with the project or initiative that I can't yet announce, but hopefully we'll be able to talk about in much more detail very soon, that's completely unrelated to HBUSD. So HBUSD, interesting economic experiment. There's potentially ways that it could be used in the economic model where we burn Hemi tokens, and it could be used as a way to, instead of completely burning them, instead burn them into this HBUSD token, which then could be used as, potentially something in the community for, buying NFTs or things of that nature. But it's really just an economic experiment. It's not something that we're focusing a lot of time or attention on. I think we did actually deploy it, but we just haven't done anything interesting around it yet. So HBUSD, we'll do something with it, and it'll be, some interesting community thing around perhaps some token burns, maybe related to the burn component of future veHEMI reward distributions from protocol fees that are collected or something like that. But again, just a fun economic experiment to play around with, not something that's meant to act as a stable coin or be redeemable for any underlying assets or anything of that nature.
Let's see. How is preparation going for guild tasks, and will there be any testnet tasks? I can take this one. There won't be a testnet for guild. When we launch with the big community initiative, it's just going to kind of come out of the gate. We are getting closer on that. I don't want to give a date, but it's going to coincide with the big community initiative, we will call it for now. So that is the response I have for that. Let's move on to some Hemi BTC questions. Why do you say Hemi bridges real Bitcoin if the real Bitcoin is locked in a vault on Bitcoin and never actually leaves the Bitcoin network?
So there's a bit semantics. For most bridges or tunnels or any sort of that class of technology, the assets technically never leave the origin chain, but they're represented on the remote chain in a way that can be safely one-to-one redeemed back for the underlying. So what we're building with HBitVM is the most pure bare metal native version of Bitcoin you can get given Bitcoin's limitations. To give an example on the Ethereum side, when you quote unquote bridge ETH to base, for example, it's still technically staying on Ethereum. It is getting locked on the Ethereum side in a way that you can mint this remote asset, use it, transfer it around, and eventually redeem it back. And that's exactly what BTC is. The Bitcoin gets locked on the Bitcoin network because Bitcoin, as a protocol, has no awareness of other chains, and so there's no possible way to move Bitcoin from the Bitcoin network to a remote chain in a way that Bitcoin is aware of. You have to lock it or encumber it in some way where it can only be then eventually redeemed by somebody burning the remote token that is backed by that underlying BTC locked in a vault on the BTC chain, and then get the native BTC back out on the Bitcoin network. So the only to get into like the technical mechanics of it, the only true type of where you can actually quote unquote move an asset between networks at a very strict technical level is if you have both chains mutually aware of each other or protocols in both chains that are mutually aware of each other and a asset that is designed from the ground up to natively be minted and burnt across those two protocols or components of the protocol running on two chains or end chains. And so you can't do that with ETH, you can't do that with Bitcoin, you can't do that with most assets. But in the space when we refer to bridging all of those assets or tunneling those assets, we're referring to encumbering them in a secure way, minting a corresponding one-to-one back token, being able to do whatever you want with that token in the Hemi ecosystem, Ethereum, etc., and then eventually redeem it back for the underlying asset.
All right. Follow-up question. Can you share the addresses of the Bitcoin vaults backing Hemi BTC?
Yeah, we are working on a transparency dashboard. Not sure the ETA on that because there are some higher priority items that the UI apps team is working on. If you want, though, you can go to the Bitcoin tunnel contracts and get the 3 current addresses used directly from the vaults. So the data is available, it's in the contracts. That's just not get into a nice UI experience at the moment, but we are working on that. But if you do want those, you can just go to the Bitcoin tunnel contract, enumerate through the vaults, and then look at vaults 5, 6, and 7. Those are the 3 active vaults on the network. And then they have a function on the smart contract to get the Bitcoin address.
All right. And yet another follow-up. Nope, there's 2 more follow-ups now. Another one just came in. All right. How can one confirm Hemi BTC is actually backed 1-1 with real Bitcoin?
So kind of building on the previous question, so if you go to the vaults, at each vault you can look up the Bitcoin address, you then look up the balance of that Bitcoin address, and if you wanted to get really fancy, there's some stuff in the contract you could do to see how much Hemi BTC each individual vault represents versus the Bitcoin address that the vault corresponds to. But the easier, slightly inaccurate, but still 99.9% correct way is to look at the total circulating supply of Hemi BTC and then compare it to the sum of the balances between those vault BTC addresses. So, and again, we're working on a transparency dashboard that'll make that easier for people to access and look at. But if you want to do it today programmatically, that's how you do it. You go to the Bitcoin Tunnel Manager contract, you iterate through the vaults for each active vault, you look up the address, and then you sum up the balances of those addresses and compare them to the minted circulating supply of Hemi BTC in the Hemi BTC token contract. One important thing to note there that people have gotten a bit confused with in the past is the Hemi BTC circulating supply on the Hemi network is the correct number to be looking at. Some people were looking at one-to-one reserves and proof of reserves, and they were adding up the Hemi BTC on the Hemi network plus the OFT version of it on other networks. And if you do that, you're double counting because all Hemi BTC is minted on the Hemi network through the Bitcoin tunnel contracts. And then if it's bridged to another network through the OFT version of Hemi BTC, it is then locked in a OFT vault on the Hemi network. And kind of going back to our previous question about bridging, this is the actual mechanics of how bridging works for almost all tokens. Then a representative version's minted on the remote chain, and then when it's eventually burnt and redeemed, then the underlying Hemi BTC on the Hemi network is released to the person who's quote unquote bridging it back to Hemi. So the actual full circulating supply of Hemi BTC is the Hemi BTC circulating on just the Hemi network, and then any of the quantities of Hemi BTC that are on other networks to the OFT standard, those are backed by Hemi BTC that's stored in the OFT blocker vault on the Hemi network.
And for the final follow-up question, how is Hemi BTC protected from post-quantum threats?
It's a good question. The reality is there's not really much you can do on the Bitcoin side to be post-quantum for any protocol doing anything on Bitcoin. That may change. So there's a few things with HBit VM that are sort of post-quantum-ish, but not fully post-quantum. So HBit VM does let us validate an arbitrary computation on Bitcoin, and so theoretically, you could make that arbitrary computation verification of, especially with garbled circuits approach of BitVM3S, you could theoretically use a quantum resistant ZK proof and validate that. It would be a much, much larger circuit instead of, 250 gigs that every participant has to store. It might be, 10 terabytes or something even larger than that. But theoretically, you could validate a post-quantum zero-knowledge proof using garbled circuits with the BitVM3S style approach, and that could plug into a future version of HBitVM. The limitation, though, is in order for any BitVM style application, including HBitVM, to work, you need something called covenant emulation. And the way covenant emulation works is you have a group of N parties who collaboratively sign the entire authorized transaction graph of all the Bitcoin transactions that are needed to construct the HBitVM vault. And that covenant emulation, it still has to use the underlying signature algorithms that Bitcoin supports. So whether that's doing some sort of threshold signature scheme with traditional ECDSA, or whether that's doing a threshold signature using Schnorr, both of those are not quantum resistant algorithms, and there's no way around the covenant emulation construction. So even if you're validating a quantum resistant ZK proof for vault withdrawal, there's still no way to protect the transaction graph covenant emulation side of the protocol from quantum computers, as ultimately Bitcoin needs to work with signed transactions that are signed in a way that Bitcoin understands how to validate, unless the Bitcoin protocol does an update that adds post-quantum cryptography, which presumably will happen at some point. But again, the Bitcoin development cycle is notoriously slow, which is both a bug and a feature. But at the moment, until something like that's added, there's no true way to do post-quantum on Bitcoin. There could theoretically be some stuff you could do, and I say theoretically because there's still some open issues with this, but potentially with Lamport signatures. Part of how HBitVM works is using Lamport signatures to securely establish shared state between different invocations of the Bitcoin script engine across multiple Bitcoin transactions. And so you can protect a UTXO with a Lamport signature, but the problem is the Bitcoin is not expressive enough to be able to import the hash of the transaction you're signing inside the script evaluation engine. And so even though we have opcodes like opchecksig, what those opcodes do is they're shorthand for checking a signature that is actually on the stack of the Bitcoin script VM against the transaction hash or a subset of the transaction that's hashed. But you don't have the ability to get that data actually pushed onto the stack where then you could compare the actual transaction data that's being signed to the Lamport signature. So you can validate a Lamport signature in Bitcoin script. You can validate signatures, ECDSA or Schnorr signatures over the contents of a transaction in Bitcoin script, but there's no way to get the contents of a Bitcoin transaction onto the stack so that you could then use a Lamport signature algorithm to verify a signature over the transaction data. There might be a theoretical way with a version of, or a modification of Collider VM that potentially could be used to make it computationally infeasible for somebody to so backing up a second, if you validated a Lamport signature in a Bitcoin script, the Lamport signature can't have anything to do with the transaction, meaning the signature is portable. And so if, say, I sent a transaction of me sending, 0.01 Bitcoin to John, and John constructed a tap script address or taproot address that had a tap script inside of it that validated a Lamport signature, and he held the private keys to the Lamport signature. Whatever he's signing with his Lamport private keys are not able to be compared to the transaction he's actually signing. So if he were to, so he could protect against somebody compromising his public key in some other fashion, because he could protect the output that I'm sending him with a Lamport signature. But as soon as he actually propagates a transaction to the Bitcoin network, he's signing something with his Lamport private keys, and those are not correlated to the actual transaction. So somebody was able to compromise his public key and recover his private key using some quantum computing algorithm. They could replay his Lamport signature used to protect his output or protect his transaction with a signature, a traditional, Schnorr signature over a different conflicting transaction. So fundamentally, there is really no way to do true quantum resistant stuff on Bitcoin. There's bits and pieces. So we can theoretically do quantum resistant ZK proving algorithms, but again, you're still limited by quantum attacks against the covenant emulation system, which necessarily has to fall back to the signature algorithm that Bitcoin understands. And for more bespoke things, even though we can validate Lamport signatures, which are quantum resistant, in Bitcoin script, we can't, we're missing that final mile of being able to actually bring information about the Bitcoin transaction into the Bitcoin script evaluation engine. And so even though we can validate a post-quantum signature, there's no way to correlate that signature with a specific instantiation of the transaction that you're sending. So that's a whole lot of detail to say. You basically can't build true post-quantum stuff on Bitcoin. You can build some post-quantum components on Bitcoin, but unless the Bitcoin protocol itself is updated to either be able to replace the covenant emulation system of BitVM style constructions with either true covenants or getting at least access to post-quantum signature algorithm that you could use for doing the actual covenant emulation side, or adding more expressivity to the Bitcoin script VM to be able to actually access transaction data and put it on the stack to compare an actual post-quantum signature to. You don't have that final mile of building post-quantum stuff, true end-to-end post-quantum stuff on Bitcoin yet. I don't know, John, if you have any other thoughts to add to that.
Yeah, quantum isn't real. There's always that little detail.
For now. Hopefully for quite a while. That tends to look.
Been hearing the story for 40 years, so the day we can factor a number that's bigger than 21, I'll be impressed.
I read somewhere that it's a physical engineering issue. There is it's a scaling matter of not like 1, 10, 20, 30. It's like 100,000 times the scale that it needs to be right now in order to function.
At that point, it stops being a scaling issue and it becomes an actual like fundamental issue. But it is true. Like every time there have been a bunch of cases where they have factored bigger numbers than those two-digit ones.
Yeah, but those are bit adjacent.
But that's just it. They factor bigger ones, but they had picked the bigger number that they were going to factor ahead of time. So, you can always stack the deck to make sure you're going to get the results you want. And it is extremely cool physics experiments, but they're still physics experiments at the moment.
What John said, it's at this time, quantum is essentially nonsense, and it sounds very impressive on paper, and the math is mind-boggling complex and fun and awesome, but it is a physics experiment, and I'm pretty. I don't want to bet on this, but I think it is unlikely that in our lifetimes we will see more than tens or hundreds of qubits ever lined up, and to break a Bitcoin key, you need quite a few more than those. So I am roughly 0.1% worried about quantum, computing breaking Bitcoin.
The other thing too is you'll hear people quote you need X number of qubits, which is always changing and generally seems to go down as people find algorithmic improvements. But you need X number of qubits to crack 256 bits of security for ECDSA or whatever. And they're referring to logical qubits, not physical qubits. Whereas the companies developing quantum computers, because it's bigger number better, they're always talking about their systems in terms of physical qubits. And you have this, I don't think it's technically exponential, but exponential E scaling problem with translating physical qubits to logical qubits. So logical qubit is an actual, I'm probably using the term slightly wrong, but coherent qubit that you can rely on and do stuff with, whereas physical qubits are, the actual physical qubits on a chip, and you need a lot of those physical qubits to be able to do the proper error correction to create one logical qubit. If you have an algorithm that needs, 1,000 or 10,000 or whatever logical qubits with, current quantum computing technologies, that might translate to something like 50,000 or 100,000 or a million physical qubits on a chip that are able to do the proper error correcting to expose 1,000 or 10,000 physical or logical qubits that you can actually reliably run an algorithm on. So not an expert in quantum computing by any means, but there's a large marketing mismatch between actual usable qubits to break an algorithm and the quote unquote qubits that people are claiming that they have a quantum computer that is, has X number of qubits. They're usually talking about physical qubits because it gets them a number that's bigger by 1 to 2 orders of magnitude. And the exponential scaling problem is, as you scale out the number of logical qubits, it's not, always say 100 physical qubits to 1 logical qubit. It's, you want to go from 10 logical qubits to 100. That's not a 10x in the physical qubits. It might be 25x or 50x because there's now, more errors to correct across more qubits, and they're all interacting in some way. And so you need more error correction that scales somewhat exponentially as you scale out the actual number of logical usable qubits in the system.
I want to disagree with something Marco said. I think there is a not huge, but real chance that quantum will significantly harm Bitcoin, but not in the way you think. Right now, a lot of the discussion in the Bitcoin dev community has been going in circles around how to add quantum resistant signing to Bitcoin, and it goes absolutely nowhere. And it is and the discussion and Bitcoin's inability to make a decision around that, the Bitcoin community, could actually cause harm to Bitcoin. So discussing quantum might be hard. I think there's a higher chance that discussing quantum will cause significant harm to Bitcoin than quantum will cause harm to Bitcoin in the foreseeable future.
Oh, I don't disagree there. And let me add one interesting tidbit that maybe that's useful for people. So Bitcoin, if you use address hygiene, you're only exposing one key per output. That is a very different problem space than Ethereum, where essentially all your Ethereum lives on the same private key. So there's also that little difference. So quantum would be much more harmful for Ethereum than it would be for Bitcoin. Again, that is probably not going to happen. Stupid error correction, stupid physics.
On paper, quantum's awesome. Like if we didn't have just this real world crap to get in the way, it really would be cool.
String is equally awesome on paper.
There's nothing like reading a paper where each equation is like 3 pages long.
Susie, anybody? I got more. Shut up.
I will say I'm probably a little more concerned about quantum computers than John or Marco are, but I still think we're very far out from actual cryptographic threats to Bitcoin and Ethereum. I don't think we're on a, in a few years type of scenario. But I think it's smart that Ethereum's working towards quantum resistance now. Might as well figure it out while we have plenty of time versus waiting until you potentially get blindsided in, a decade or 2 decades or whenever they actually become practical.
We're also both older than you, so statistically, you have a better chance of living to see quantum being a problem than us.
That is fair. Although, we'll see with the number of energy drinks I drink, you guys might see quantum and maybe I won't.
Well, and let's also not forget the other tiny little, elephant in the room about how the quantum algorithms are distinctively less studied than the traditional ones. So we have 40 years on stuff like ECDSA, and that's a feature. That's not a bug, right? This is not because newer stuff is more awesome. This is just it has held the it has held its own for over 40 years. So a bunch of the lattice constructions are still not widely understood. So I actually think that it's more dangerous to introduce a signing algorithm that is quote unquote quantum resistant than sticking with the stuff and has not been broken before.
The cool stuff is with a little loss of efficiency, though, you can get the best of both worlds. So kind of like how we're doing for most of the ZK stuff we're working on, prover diversity. So if there's a bug in one ZK proving system, well, you'd have to find a very similar bug in the other 2 ZK proving systems to break it. You can do a phase transition where instead of just signing with ECDSA or just signing with, insert XYZ, Falcon or whatever post-quantum signature algorithm you want, just sign with both. And if ECDSA can't be broken by quantum computers yet, then you're fine even if the quantum algorithm ends up being completely broken, which we've seen in the past. There's been
psych, literally called psych.
Yep. the irony.
It's in the name. Your algorithm broke because of psych.
Yeah, I think we've I'm forgetting the name now, but there was another one that was broken relatively recently too, or at least the number of bits of security were dramatically reduced to where it's might as well consider it broken. I'm trying to remember.
So psych was the one that made it into the NIST list as a finalist, and then somebody broke it on a laptop within the hour with some clever math.
I thought there was another one too more recently.
Rainbow, is that the one you're talking about?
Maybe it was Rainbow I'm thinking of. All cryptographic signing algorithms rely on a trapdoor function, which is something that's easy to do one way, and we're pretty sure that it's hard to do the other way. And so, RSA is factoring big integers, and with these, ECDSA is being able to undo point addition on an elliptic curve. And with these quantum computing algorithms, well, first, the reason that we know RSA and ECDSA are not quantum resistant is because somebody, a la Shor, figured out an algorithm for solving the discrete log problem on a quantum computer, or the ECDSA variant of discrete log. And just because we haven't figured out a way to solve some of these other problems on a quantum computer yet efficiently, doesn't mean that somebody won't figure it out. So you look at a lot of the lattice stuff, it's based on learning with errors, and basically is a very terrible summary, but being able to efficiently find paths or the closest elements in a n-dimensional lattice of points. And so the current thinking is we don't know any quantum computing algorithms that can do that efficiently, and therefore we assume that anything based on learning with errors as the hard cryptographic problem or the trapdoor function is secure against quantum computing attacks. But so what Marco brings up is the algorithm might just be broken classically. So like Rainbow and Psych, and I'm pretty sure there's a third one that I can't remember right now, but maybe I'm mistaking it for Rainbow. But those were broken with not quantum computers, just the algorithm was broken. So if you had adopted those, you're actually worse off than if you had just kept using RSA or ECDSA. And there's, cryptographic algorithms generally evolve. You can't just prove that an algorithm's secure. It's mathematically impossible. Instead, it has to live long enough for enough people to attempt to break it and fail that we're pretty sure that nobody can break it.
Max, so if we could just add into that, Bitcoin has $1 trillion bounty on that working, right? So if it was actually possible, people would be doing it.
Oh yeah, and so we're pretty sure ECDSA and Schnorr are secure against classical attacks, but there's no way to mathematically prove that, right? The proof is, there's $1 trillion bounty and no one's done it. That's good enough proof for me, but again, it's mathematically impossible to prove that an algorithm, that a trapdoor function used for a cryptographic algorithm is truly a hard problem to do in reverse.
And then there's also your implementation.
Yes.
Because the algorithm's got to be good, the implementation has to be good, and then to make life just a little bit worse, the hardware that it runs on has to be good.
You forgot the whole infrastructure play.
I try to forget that one.
Right. Now, but I actually do believe that ECDSA could fall to a classic break over a post-quantum break sooner. That would be my true expectation on this particular scenario, but that's a personal view.
And if you're really concerned about post-quantum stuff, there's not too much you can do on Bitcoin, but as Marco mentioned, at the moment, not reusing addresses and obviously using an address that's not actually just a public key, which is pretty much all Bitcoin addresses today, unless you're doing something really dumb. But that does protect you because, as far as we know, there's no efficient way to reverse a hash function on a quantum computer. You have Grover's algorithm, which reduces the bits by a factor of 2. So you go from SHA-256 to, equivalently SHA-128, but also you can iterate much slower on quantum computers. So it's not quite as bad as SHA-128, which is already still extremely secure. But at the moment, the best thing you can do on Bitcoin is put the Bitcoin in a address that you've never used, because when you use it, you have to reveal the private key so that the Bitcoin script can actually validate that your private key hashes to your address, very informally speaking, and that then the signature corresponds with the public key. So there's this chain of signature validates with public key validates with address. And if there were to be a quantum computer or even a classical attack against ECDSA or Schnorr, then if you're storing Bitcoin in an address that you've never sent an outgoing transaction from, then you've never revealed the public key. And so the only time that somebody would be able to attack it is actively when you've done a transaction and it's sitting in the mempool and they're able to see your public key from the transaction and then potentially attack it. So avoiding address reuse is, if you want the best quantum defense you can do on Bitcoin today, that's how you do it. With HBitVM, the Covenant emulation system will be, using new keys for each setup ceremony, and so there's, some concept of non-address reuse, although the macro public key is public as part of the protocol, so it's not quite quantum resistant. There may be theoretical ways to improve that, but they require potentially more engineering and make the system less efficient. And but on Ethereum or on Hemi, you could implement post-quantum. People have actually built reference implementations of post-quantum cryptography that you can deploy as a smart contract. And so sort of like you can have a multi-sig, formally Gnosis safe that you have to sign with a traditional ECDSA key. You can also build a contract that can validate signatures with a quantum resistant algorithm. And so you could theoretically deploy quantum resistant fund storage on any EVM chain today if you wanted to. Some people have done that to a limited extent. The problem is it's very inefficient. It's very expensive to validate post-quantum signatures in an EVM right now, or at least, again, what we believe are post-quantum signatures, and so it doesn't really caught on. And then talking about, on the Ethereum side, what Ethereum's doing for post-quantum preparedness, there's sort of three, we've already gone through this in previous weeks, so I won't make this into a ridiculously long segment, but there's a couple things about Ethereum that make it particularly challenging to be post-quantum. So on Bitcoin, proof of work is already quantum resistant. It's SHA-256, and again, nobody's going to be using Grover's algorithm to mine Bitcoin on a quantum computer. It's just impractical from a efficiency gain sense, at least as far as everything we're aware of. So really the only issue is the signature algorithms, and Bitcoin uses simple signatures. That's to say that when you send a transaction, you're signing something with one key or one threshold key, or a small number of keys in a traditional multi-sig setup on Bitcoin. And so it's really just a matter of, on Bitcoin, swapping out signature algorithm A for signature algorithm B, and making sure that the verification is efficient enough that it doesn't, cause a denial of service on the network when it's operating correctly.
But I was going to say, there's another simple trick, really simple trick, but very effective, is pay the script hash. I think a lot of people underestimate just how powerful that is.
Yeah, I mean, do you want to expand on that a bit?
No, you go ahead. I just wanted to give you that tidbit because you will probably do it more justice than I could.
I mean, pay to script hash, speaking from a quantum perspective, it kind of already what I covered, which is you're only exposed to a quantum attack if you're not reusing addresses when your transaction's in the mempool. So the other cool thing with pay to script hash slash now the additional flexibility you can have with TapScript is, or let's talk about TapScript specifically because I think it's interesting here. You can have, so normally on Bitcoin before Taproot TapScript, you could only have one spend script, one script that's protecting your Bitcoin in a output. And that you could have some branching logic in that. So you can have, if this, do that, else do this. So you could have, for example, an algorithm that, or a unlock script that says, either, not an unlock script, but a script that's protecting your output that a script sig satisfies, that says, either you have to provide a 2 of 3 multi-sig, or you have to wait a year and sign with a single key, or things like that. So you could do these very simple, if-else constructions, and you could get some surprisingly complex logic just by doing that. But again, it was still pretty limited. With TapScript, you can basically take that if-else branch and you can deconstruct that into a basically unlimited, from a practical perspective, number of individual scripts. So it gives you better privacy from the perspective of when you did eventually, say, spend that original script that was, either 2 or 3 multi-sig or wait a year and sign with this one key. When you eventually spend that output, whichever way you spend it, you're revealing that was originally that you're revealing everything about how that script was originally constructed. And so whether you do the 2 of 3 multi-sig or you wait a year and do the one signature, when you do spend it, you're revealing to the world that the way that it could have been spent was either of these two options. And with TapScript, and so you have a privacy problem of you're revealing everything about the potential logical paths that could be taken during Bitcoin script execution, but also from a efficiency perspective, you're revealing, you have to pay transaction fees for all of the data in the spend script, whether that branch is being used or not. And so if you had some really complex construction like, either a 49 of 51 multi-sig, or wait a day and then it's a 48 of 51, or wait 2 days and then it's a 43 of 51, whatever, you hit practical limits as to how many branches you can create, and then you're paying, regardless of which branch you actually use, you're paying for publishing the entire script that explains all of the potential branches that you could have took during execution. And with TapScript, what you're able to do is separate each of those potential conditions into their own script, and then only reveal the script that you're actually using to spend it. So you get the privacy of, if you did the 2 of 3 spend path, the wait a year and 1 sig spend path is not revealed, or vice versa. But you're also getting the efficiency benefits of only having to reveal the logic branch of the Bitcoin script that you actually ended up executing. And so from a quantum resistant lens, I suppose, that also gives you some additional benefits where you can say have a one single LAN port private key, and you could set up multiple different TapScript addresses that you're using, and you could bury that single LAN port key inside of one of the spend conditions for each of those addresses. And again, this is not recommended. The ideal way would still be to have individual LAN port keys for each of the TapScript addresses you create, and then only ever receive one output to each TapScript address, or receive multiple, but always spend them all atomically at the same time. But that additional privacy that you get lets you do some more creative stuff with, potentially being able to have spend paths that people, you're not revealing them. To give a concrete example, if you secured a output with a LAN port script, then even if you did address reuse, until you actually reveal that LAN port signature spend path, nobody knows that LAN port key. So if you're using that to secure other TapScript addresses with that same LAN port key buried in one of the spending branches for those, nobody would be able to know that they could attack that address if they compromised that other private key for the TapScript address, but didn't have the LAN port key until you actually spent a transaction, and then you're only exposed for the time that it's in the mempool. So there's some cool stuff you can do with TapScript that's interesting and lets you, build in future spend paths that you may want to use but not expose every time that you use the address currently, or use any one of a group of addresses. So maybe that's a future breakout item to discuss in more detail, but there's some cool stuff you can do that. And then, as Marco was talking about, the traditional just pay to script hash lets you define any arbitrary script and not reveal it until the time that you actually spend the transaction. So it's sort of like TapScript, but you don't have the ending condition. So your script itself is private until the time that you actually use it. But unlike a TapScript address where you could theoretically reuse a TapScript address multiple times with different spend paths with pay to script hash, the first time that you do a spend from it, you're revealing all of the spend conditions that are coded into the locking script that you're using.
But there's all kinds of other cute things hiding in pay to script hash, right? Because if you pad the script with a 0, you already completely modify the hash. So there's all kinds of really neat things that you can really do with it to really help you here. It's pretty subtle, but the pay to script hash is actually incredibly secure, provided you don't reuse addresses.
Yep, from a quantum computer resistant angle, you're basically only exposed for the time that your transaction's in the mempool.
Right, and if you send Bitcoin from pay to script hash to a new pay to script hash, it immediately gains those properties right back.
Yep, the padding idea is there's some cool stuff you can do with that where you can basically reuse the same keys. You only have to manage one key, but like Marco said, you can keep changing the script so that you're getting tons of different addresses that are still fundamentally backed by the same key, but they have slightly different scripts, so they hash to different results and give you different addresses. So there's some cool stuff you can do with that let you essentially, again, have a single key and then reuse it in a more secure way. Although if you do that, you do have to be careful about the grinding attacks against the padding. So if you said, if you had a very uninteresting algorithm for the padding, somebody could theoretically predict that and then use that to grind all of the script hashes that are related and controlled by the same key. So there's some cool stuff there, but if you're going to implement that kind of system, you have to be careful how you implement the padding, or else it could theoretically be brute forced.
Well, the padding should be an HMAC with a key and a domain separator, and boom, it's over.
Yeah, and you could also do some interesting stuff with key derivations. You could have, and again, this would sort of defeat the purpose of doing it in the first place, because if you're already doing, HD key derivation, then you probably don't care about reusing the same actual key in multiple places and keeping it obfuscated. But you could do some sort of, HD based derivation where, instead of using HD for getting new keys, you're using HD for getting unpredictable padding to add to transactions. Or, more simply, you could do like a hash onion approach where you start with some, say just the private key itself, and then each time you create a new data script hash, you do another. You basically you create a bunch of hashes in one direction, so the hash of the hash of the hash of the hash of your private key or whatever, and then each time that you create a new data script hash that you're using, you walk back in that chain one. You don't want to walk forward because then somebody could just play it forward. But you walk backwards in that hash onion, quote unquote, and then that gives you a way where you can always deterministically rederive all of the, pseudo-random padding bits that you're using from your single private key, but they can't be predicted by anyone as long as your system is securely only revealing one step backwards in that hash onion at a time. So there's probably better ways to do it, but that's one easy way to do it where you're not introducing more complex data management to be able to recover access to your scripts beyond just having to keep access to your private key.
What Max is saying with a lot of words is Bitcoin is pretty quantum proof.
Pretty, and depends on how you use it. And unfortunately, some of the things that you have to do for a HBit VM style construction with the covenant emulation are not using. It's hard to use the true best practices of, quote unquote, no address reuse or no public key reuse. And there may be ways to improve on that, but that's an open area for future exploration. But Bitcoin will never be truly quantum resistant until they add a quantum resistant signature algorithm to the protocol, or they allow enough expressivity for you to do actually you can already evaluate Lamport signatures, but to be able to actually compare the signed message to the transaction itself that's being signed instead of to an arbitrary message that's pushed onto the stack, like you do with BitVM constructions.
All right. Let's see. Oh, we are over. We have time for probably one more. Let's see. Recently there seems to be less response and engagement from the team compared to pre-TGE and post-TGE periods. Could you provide some clarification on this?
I'd say the biggest part is we're busy building. Pre-TGE, there was a lot of kind of waiting around for third-party stuff to happen, and so you'd see me in Discord more because we're waiting on third parties for stuff, and now we're in the phase of Hemi where it's obviously we're working with third parties, we're working with partners, getting them onboarded and deployed on Hemi, but most of our major items, at least on the engineering side, are all things that are completely in our control and things that we're working on actually getting built and shipped. And so there's never idle time to just hop on Discord and talk with the intern for a few hours because there's a ZK proof marketplace and MinerFi and HBit VM and the ZK proving system for Bitcoin to build. And so I'd say that's probably the main reason, at least from the engineering side. We do want to get community engagement up, and part of what John was talking about with some of the new initiatives we have planned should help with that, both on the general community side, but also specifically on the developer side. But yeah, pre-TGE, there was free time while we're waiting on third parties to do stuff, and right now there's an endless amount of work for everyone to do, and the faster we get it done, the better. So
also, it's kind of ironic to ask about engagement from the team when the team is sitting here talking to the community. Like we do still do things like Midweek with Max, which is very literally the team, reasonable chunks of the team taking a good, time out of their day to be part of the community. Like, this is us engaging with people and rambling about quantum. Yes, there is that too. But
There is that, but no, really, yeah, we've been doing this for going on 2 years now, and there's actually going to be more things like this coming up with the big community push that John was alluding to, that I will not allude to further because I'll end up giving something away.
every word you say, you get closer and closer to giving things away.
I know, that's why I'm going to shut up about that now and ask one more question. But oh, actually, hold on. I have a note here to plug the builder role as well as open source contributor. So yeah, build and get the builder role. It is readily available, as are the creative roles in Discord. Oh boy. All right. This is a big one, but I think we can end with this one. What is the status of the move to Rust-based opreth?
We're gonna be here for another hour.
Try to keep this one short. So this one basically, for context, so Optimism Upstream is deprecating opgeth on, I believe, May 31st as the official deprecation date, and then the sort of true things break if you're not converted over to opgeth happens when the next Ethereum hard fork happens post May 31st, whenever that is, which is yet to be scheduled by the Ethereum community, but my guess is probably sometime in June or July. And so, because opgeth's getting deprecated upstream, we have to convert everything that we're currently doing in opgeth, which includes HVM, which itself includes the entire Bitcoin indexing system that powers the HVM precompiles, as well as our other changes for the new POP payouts transaction type, for example, changes we made to peer-to-peer to be able to backhaul Bitcoin transactions, or Bitcoin blocks rather, over peer-to-peer if they're not available on the Bitcoin network via what's currently TBCs, and in the future what will be either something called Trust slash our Bitcoin ZK index or Oxygen. And so all of those changes need to be converted into Rust and integrated into opreth, so that when opgeth gets deprecated, all of the features on the Hemi network continue to run as expected with our fork of opreth. So some of that is work that we were doing or had to do anyway for ZK provability, because most of the ZK prove, well, I'll say all of the ZK proving stack essentially in the Ethereum ecosystem is based around Rust, the Rust implementation of the EVM for Optimism style or Optimism based chains. Their system called Kona, which is their Rust version essentially of Opnode and some other subcomponents therein. And so some of the work was stuff we had to do anyway, but making opreth, changing the roadmap from opreth only in support of ZK provability, which means you don't have to worry about peer-to-peer messages, you don't have to worry about optimization for some things around, say, the Bitcoin indexer, queries against the Bitcoin indexer, things like that. That now changed to having to get opreth fully compatible with all features to be able to be completely equivalent to opgeth. And so we started on that, I think, roughly 2 weeks ago. And it's moving along. We don't expect any issues in hitting any of the deprecation deadlines. Right now, a lot of the work is around what we're calling Trust, which is a Rust fork of essentially TBC, or all the functionality that TBC provides in the opgeth stack, to be able to replicate the Bitcoin indexer, both the indexer advancement and also queries against that indexed Bitcoin state for HVM precompiles. We have two different development tracks. So there's a development track that I started prior, which was just getting opreth caught up with opgeth only for the features needed for ZK provability. And so that's sort of running in parallel to this new work, which is actually translating and getting a full, live version of TBC converted into Rust. We are, maybe there's a little bit more detail than people care about, but if you're interested, we're building Trust in two phases. So the first is basically the lightweight Bitcoin consensus, or the header-only mode of TBC, and getting that working with a RPC pass-through to TBC. And so worst case, if we needed to move over to opreth sooner, or in practice what this means is we can start battle testing opreth sooner without all of the components being built to make sure all the other pieces, like the new transaction types and things like that, are working correctly. So the first version of Trust is a REST implementation of the Bitcoin lightweight header-only mode consensus stuff, and then a RPC pass-through to TBC under the hood for the full Bitcoin indexer. And the second version of Trust is a full conversion of TBC from Go into Rust, including the much heavier, much more complicated Bitcoin indexing piece of it. So moving along, and there's sort of these two different parallel tracks of the original ZK work and now the work that is all of the ZK stuff plus all of the other things that are needed to actually run a node in production versus a node in just a ZK mode where things are a little different and you don't need to worry about optimization of some components quite as much.
All right. With that, we are very over time, so I think we're gonna wrap things up for this week. But before we go, please stay tuned for our April engineering AMA, which I believe we still need to pick a topic for, but hopefully next week or the following week we'll be having that. And Jeremy, do you have anything from marketing you wanna promote?
Yeah, just keeping in mind that you guys would like to see more members of the Hemi team, we are trying to commit ourselves to doing more live streams. So, in addition to that engineering AMA, this week on Friday, Max will be joining me to speak more about the future of ZK markets and what that means for Hemi. So we look forward to seeing you there. We'll be setting up a channel here in Discord later in the very near future for you to pose all your questions about that topic to Max. And remember, this is a ZK related topic, so get ready for a wild ride.
And one final thing I'll add for the we did get some questions about DeFi Llama and the way that I think protocol revenue is showing up. So I just looked at this shortly before this call, so I haven't been able to deep dive. But there definitely does seem to be some data issue on DeFi Llama. As an example, they're showing $150 of fees in the last 24 hours on Sushi, but then they're showing a total app revenue of $100 for the month of March. So obviously that doesn't make sense if one single protocol made more revenue than that in a single day in March. So not sure quite what's going on with DeFi Llama. We have had some data issues with them in the past where either protocols were being tracked correctly and then for some reason they stopped being tracked, or they were still being tracked but the data wasn't being pulled correctly. So no, not sure what the root cause is, but there is definitely some sort of a data issue on the protocol revenue side of DeFi Llama if you're looking at that and wondering why the numbers don't look correct.
Thank you for addressing that as well. With that, we are going to wrap things up this week, but please join us on Friday for a little more ZK action featuring Max, Jeremy, and possibly some other members of the team. I got word it won't be next week, but it will be the following week. We'll be doing our April engineering AMA. And please stay tuned for some big community updates. I'm not going to say anything else because if I give something away, John will punch me in the throat. So
I know where you live.
yes. Alpha is asking if I can explain ZK. Funny story. I think we're going to do that as an episode of Teach Rick Crypto. We really should do that.
You should.
We really should do that.
I
You
don't
ought to do it.
but I don't think we're gonna be able to do it. So I think it's fine to talk about the joke. We were discussing doing a episode of Teach Rick Crypto, but instead it'd be the April Fool's edition of Rick Teaches Crypto. We were going to give him a script of this like really complicated part of either ZK provability or FHE or something like that to just like read off. But again, since April 1st is tomorrow, I don't think that's going to happen. So instead, I will just share the idea and maybe we'll do something like that next year.
Reasonable. Now I have to come up with a new April Fool's Day joke. Damn it. But yeah, no, that makes total sense because yeah, the odds of us being able to record that tomorrow probably are slim to none. But it would have been a hell of a joke. Explain P2SH. I could, Marco, but I mean, come on. You know, if I do that, then People are going to be asking me questions all the time, and we can't have midweek with Rick. That just isn't good. So I'll hold off on explaining that for a future date. How about that? Your silence means everything.
Well, eventually.
No, it's a relatively simple thing, and I would love to hear your explanation of it.
Well,
Yeah, Rick.
you know,
Come on, hit it.
when a
I think Marco just volunteered to do an episode of Teach Rip Crypto about P2S.
yeah, I think so. Marco, I'm gonna need to be schooled on this, so we're gonna need you for the next episode. JCV, if you could coordinate that, please.
I think we can make that happen.
No good
I
deed
was
goes unpunished.
bluffing.
Well, I'm not.
If you teach me what it is, I guarantee I'll be able to say what it is to the community.
Wonderful.
So let's do that. All right. Well, we got our next Teach Rick Crypto episode lined up. That's awesome. Expect the first one to be dropping around the community, the big community thing. Damn it, I almost said it again. John.
Just stop talking.
I know. Okay, with that, if anyone has an outro, please say it now. Otherwise, thank you to the entire community. Thank you to our community moderators. I'm going to kick it off to Max and Co. for outros, and I'm going to shut the hell up.
All right. Thanks, everyone, for joining us for another week of Midweek with Max, and look forward to seeing all of you next week. If you're interested in being the first to play around with some of the new stuff that we're working on behind the scenes, the MinerFi/FastBridge protocol, still working on a marketing name for it, some of the ZK Marketplace stuff, or any of the other smaller things we're working on that'll be coming out in the somewhat near future, like the Hemi shared security/restaking system. Definitely make sure you're in the beta testers channel, because that's where we'll roll it out first. And we will see everyone next week. Or on Friday for the ZK Marketplace daily discussion. Not even sure what format it's going to take, but it should be interesting, especially if you followed some of the other projects like Boundless or what Succinct is doing with their prover network. Or if you've been a developer working on some of the ZK stuff and run into problems with compute complexity, especially around things that don't need private inputs. So things like interoperability protocols or offloaded computation verified in EVM. We'll be covering what we're doing for building a ZK marketplace and what we're doing different that we think makes it more accessible for developers, and hopefully what that means for the Hemi ecosystem as well, and how it relates into the Hemi token economics as a new revenue stream for people to contribute to the ZK proving marketplace. And yeah, well, it should be an interesting discussion. So hopefully we'll see some of you there, and we'll see the rest of you next week.
Keep your eyes peeled for the announcement and the channel where you can pose all your questions for Max. And we do look forward to seeing you there.
Take care, amigos. See you Friday. See you in Discord, and see you next Tuesday for more Midweek with Max. Take care, y'all.
All right. Cheers.
Bye.